What does it truly mean to be alive? It might seem like a simple question, but when we dive deeper, the answers become surprisingly complex. Life surrounds us every day, from the tiniest bacteria in a drop of water to the towering redwoods and the beating hearts of animals and humans. But have you ever wondered what really separates these living forms from the rocks, rivers, and mountains that make up the rest of our world? Scientists, philosophers, and thinkers across history have struggled to define life. At first glance, life seems to be about movement, growth, or awareness. But if we consider the behavior of certain machines or even complex software, they too sometimes seem alive in their interactions. Can we say they're truly alive? Or is there something else that distinguishes living things from non-living? To define life, scientists have identified a set of core characteristics that most living things share. These characteristics are often thought of as the minimum requirements for something to be considered alive. Firstly, metabolism, the process through which organisms convert energy to fuel their activities. Think of it as the engine that powers life. Next, there's growth, the ability to develop and change over time. Reproduction is another hallmark. Life creates more life, whether through seeds, eggs, or cell division. Living beings also respond to stimuli. They sense and react to their environments, ensuring their survival and adaptation. Adaptation itself is another crucial trait. Over generations, life evolves, changing to better fit its environment. Taken together, these traits create a checklist scientists use to determine what is and what isn't alive. But not everything is as straightforward as it seems. Consider viruses, entities that blur the boundaries between life and non-life. Viruses can reproduce, but only within a host cell. They adapt over time, evolving new ways to infect, yet they lack their own metabolism and cannot survive independently. Are they alive? Or are they something entirely different? Viruses aren't the only exception. Other borderline cases, such as prions, infectious proteins, challenge our ideas about life's boundaries. These exceptions suggest that life might not fit neatly into a single definition, and that the line between living and non-living may be more fluid than we thought. If we look deeper, life on Earth is built upon a chemical foundation. At the heart of this chemistry are molecules like DNA, which carries genetic information, and proteins, which perform vital functions within cells. These molecules are organized in specific ways to support the processes of life. One of the most essential elements for life as we know it is carbon. Carbon's unique bonding properties allow it to form complex molecules essential for building life. But could life exist without carbon? Scientists are exploring the possibility of silicon-based life, or even life forms we haven't yet imagined, challenging the idea that Earth's biochemistry is the only pathway to life. Life has been a subject of fascination, not only for scientists but also for philosophers. In ancient times, life was often attributed to a vital force, something mystical and unseen. While science has moved beyond these ideas, some modern thinkers suggest that life might involve more than just biology. One such idea is that of emergent properties, the concept that life is more than just the sum of its chemical parts. Could there be something intangible, an essence or a quality that brings life into existence, one that cannot be entirely explained by physical components? Another intriguing question is the relationship between life and consciousness. Some say that consciousness, the ability to be self-aware, to think and perceive, may be what truly separates life from non-life. While bacteria and plants are certainly alive, higher animals and humans experience a unique kind of awareness. Does consciousness make us more alive, or is it merely a complex trait of life? With advances in artificial intelligence, the line between life and non-life becomes more blurred. Could an AI one day be considered alive if it demonstrates behaviors similar to consciousness? Or is life something that cannot be replicated by machines no matter how advanced they become? As we look beyond Earth, we face one of the most captivating questions in science. Could life exist elsewhere in the cosmos? And if so, would it follow the same rules that we observe here on Earth? To answer this, scientists are studying planets and moons within our solar system, focusing on places where life, if it exists, might thrive in ways radically different from what we know. Let's consider Mars, a dry, cold desert with a history of water flow. Scientists believe that if life ever existed on Mars, it might have adapted to the planet's harsh, dry conditions. Meanwhile, Europa, one of Jupiter's moons, hides a vast ocean beneath a thick layer of ice. Here, the warmth from volcanic activity on the ocean floor might create an environment similar to Earth's deep-sea hydrothermal vents, which support rich ecosystems without sunlight. Then, there's Titan, Saturn's largest moon, with lakes of liquid methane and ethane on its surface. Life on Titan, if it exists, might not rely on water at all. Instead, it could be based on methane, using liquid hydrocarbons in place of water for essential biological functions. Imagine life forms with biochemistry so different from ours that they could only survive in environments toxic to life on Earth. These environments challenge our Earth-centered definition of life. They lead us to question whether carbon and water are truly essential for life, or if life can adapt to entirely different elements and conditions. Could silicon replace carbon? Could ammonia replace water? Some scientists believe that the building blocks of life might vary widely across the universe, adapting to environments as diverse as the cosmos itself. And what would these life forms look like? Would they be single-celled organisms drifting in alien seas, or complex multicellular beings like us? Could they even think and feel? Our search for life in the universe has only just begun, but already we're realizing that life may not look or act anything like the forms we know. It's possible that life exists in ways we can scarcely imagine, in forms, places, and chemistries far beyond our experience. In the end, life remains one of the universe's most profound mysteries. Could there be forms of life so unfamiliar to us that we might not recognize them as alive? Or is life something that can only be fully understood by those who are themselves alive? As we continue exploring the universe, we might come closer to understanding life, or we might simply discover that life is far more mysterious than we could ever imagine. Thank you for joining me on this journey to uncover the nature of life. If you enjoyed this exploration, don't forget to subscribe and let me know in the comments what you think defines life. Until next time, stay curious.